good to go. Thanks, Kevin.
Great.
Hi everybody, and welcome back. We are now on to the Behavioral Ecology Part 1 section of the agenda. As mentioned before, there is a slight change to our program. We will be breaking early for lunch. And now, in addition, I'm going to be moderating the next couple of sessions for behavioral and ecology. So happy to help out here. To get us started, I'm happy to introduce Tom Stephenson. He's with the California Department of Fish and Wildlife, North Wildlife Supervisor and Program Leader for the Sierra Nevada Bighorn Sheep Recovery. He will be discussing energy conservation in resident bighorn herds. And with that, I'm going to pass it off to Tom to share his screen and kick this off. Thanks, Tom.
Thank you. Let me get this loaded real quick. That look good?
Looks good, and hear you well. Thanks.
Great, thanks. Hi everyone. I've enjoyed the conference so far. I do wish that we were in person there in Alberta, so I could have heard Helen cursing this morning in Sanskrit, but I guess I'll have to wait for another meeting that hopefully she'll attend even in retirement. So yeah, today I'm going to be talking about some energy conservation strategies in bighorn sheep. I'm specifically going to be discussing Sierra Nevada bighorn, which are an alpine subspecies of bighorn. They're endemic to the Sierra Nevada mountains in California. They're recognized as a federal endangered species in the US. It's actually been a pretty neat system to work in. And I'd like to acknowledge my co-authors down here. Most of us are associated with California Department of Fish and Wildlife. We run the recovery program. But I also have some co-authors from UC Davis and University of California, Davis and University of Wyoming. So essentially, almost all of our individuals, some are in the Alpine, have access to high quality forage during the summer and fatten up in preparation for winter. And Alpine here, the tree line's about 3,300 meters and rises up above 4,000 meters. The highest peak in the lower 48, Mount Whitney, is actually in the Sierra Nevada, and that's part of this recovery area. The Sierra Nevada does experience extreme snowfall. It's a mountain range that receives a lot of moisture from the Pacific Ocean, but our winters are variable. Some can be relatively dry and some can be extremely wet, a lot of snowfall. So that makes it important for sheep to know where to winter to be able to survive these snow conditions. And we see two different strategies here. One is where sheep move to lower elevations. In some parts of the range, they can move as low as 1,500 meters and really get below the snow line. But the other strategy is to winter in the Alpine on wind-scoured ridges, and some of the other projects have talked about sheep doing that during this conference. And in particular, in the Sierras, we get extremely high winds that follow these storms, in some cases, 150 miles an hour or more. So they do a good job of scouring the ridge lines of the snow, and sheep can survive the winters up there. Since the recovery program started in 2001, we've captured and collared over 500 bighorn sheep, and we handle both males and females. And we typically put GPS collars on almost every animal we handle. One thing we've started doing in recent years is using these activity monitors. And in particular, we're using the accelerometers on some of the GPS collars. And I should mention that the data that I'm going to present today is relatively preliminary. We don't have a large sample size of those accelerometers data in yet, but it's turned out to be a pretty neat tool, and we have had the ability to validate these, and I'm going to go into that in a little bit here. To give you a little bit more of a sense of the geographic extent of the study area, and the whole historic range was about 10,000 square kilometers. And currently, following some reintroductions in the recovery effort, we're up to about 14 subpopulations or herds. At the northern extent of the range, they're using Yosemite National Park, and at the southern extent, Sequoia and Kings Canyon National Parks. It's a diverse study area with populations on the west side being more forested, much more so than on the east side of the Sierra Nevada, where we have a rain shadow. And the elevations vary quite a bit over this latitudinal gradient as well, and the types of winter ranges available to them. So across those 14 subpopulations, we see some differences in the proportion of the population that winters in the Alpine. And Derek Spitz was a grad student of mine that did some work on this, on these migration strategies. And one thing that predicts the proportion of the population that winters in the Alpine has to do with the availability of low elevation winter range to those populations. We recently published some work on nutritional condition in bighorn sheep relative to population performance. And I just threw this graph in to illustrate that in some of our populations over on the right-hand side under the indicated by the ellipse there, you know, we have animals that go into winter with in excess of 20% body fat. If they're non-lactating and lactating animals, you know, upwards of 15% body fat. And those energy reserves become particularly important for these animals that are wintering in the Alpine. Some of Derek's work, for part of his work involved developing resource selection functions, and he developed those for the different seasons and the different strategies. And so one thing we see is that, as I mentioned earlier, and this is just one of our herds, the Wheeler Ridge herd. This image represents one of our sort of the steep escarpment on the east side of the Sierra. The maximum elevation in this is approaching 4,000 meters, and the base of the escarpment there is down below, well, probably approaching 1,500 meters. So, you know, it's almost 10,000 feet of gradient. But these animals summer in the Alpine, and then in the winter, as I mentioned, the one strategy is moving to a low elevation winter range to get below that snow, and conversely, wintering in the Alpine. So we hypothesize that these Alpine residents are conserving energy by moving less during winter. And these two images here illustrate, you know, the conditions that these animals are experiencing. When they get below the snow line, they have green up much earlier. They're not having to travel through deep snow. So I became particularly interested in this question of what their strategy is up there in the Alpine. So first I want to discuss some of the home range analysis that we've done, and we're looking at home ranges over short time scales in this particular analysis. This is 95% kernel density estimate or home ranges just calculated for February and March to give us a sense of how large of an area those animals are using. And as you can see in the left-hand graphics, that the resident home ranges are quite a bit smaller than the migrant home ranges for this time period. And we've seen, during severe winters, we've seen some of those home ranges be less than half a square kilometer for months at a time. If they're in a situation where they don't have to be too concerned with predators at that elevation and under those snow conditions. And the primary predator here of adults is mountain lions. But we do see variation relative to the winter severity. And so during these dry winters, as indicated in the graphic on the right, they travel quite a bit more in the Alpine and cover much larger areas when they're not confined by deep snow conditions. So the particular measure of activity that we're using is this overall dynamic body acceleration, which is the ODBA abbreviation. It's a measure of a three-dimensional measure of how that accelerometer is moving within the collar. It's recorded depending on the particular collar we deployed, every minute to minute and a half. And so it's giving us a continuous measure of activity throughout the day. And as I said, we were able to calibrate this by directly observing and recording observations of animals that were wearing these accelerometers, and then we eventually got the collar back from those animals. And so we were able to calibrate it. And really the key thing here is, and we were primarily interested in differentiating between bedding and feeding behaviors, and that takes up the vast majority of the time of these individuals, which you can't really tell from this graphic, but what this graphic illustrates is that any value of ODBA below 50 is roughly about where we determined that those animals were bedded. And if it was above that, they were either traveling or feeding, but the vast majority of the time they're feeding. And so for the purpose of this presentation, we've simplified it to really just talk about the time spent feeding. And I wanted to include a few graphics here that just illustrate what one day of data looks like for these animals in these different environments. So during the summer, these animals, and again, keep in mind that an ODBA value below 50 indicates bedded. So we do see, what appears to be, foraging throughout the nighttime, the dark period, but high levels of foraging throughout the day, much less time spent bedded. When we look at animals on a low elevation winter range during winter, there's more time spent bedded, and less time spent feeding, but they're still, feeding throughout the 24-hour period. And then in contrast, when we look at an individual that's wintering in the Alpine, and this happened to be an individual during, fairly heavy snow winter, they appear to be very inactive for much of that 24-hour period. And then with a primary spike of foraging in the middle of the day, a little bit of bedding, and then some additional foraging. So I think one thing that's really interesting about this ODBA data is that we're able to really get a handle on the time spent foraging over that 24-hour period. And I know there's a number of folks, Catherine and Marco, that have done work on foraging and time spent foraging, but I've certainly done some as well with direct observations, and obviously we're somewhat limited as to what we can get over a 24-hour period. So this is kind of a neat complement to the work that's been done already. And to give you a sense of what the foraging patterns look like over month by month, and I've just broken this into 6 summer months and 6 winter months, just to give you just to use fewer graphics here. But as you can see, in April they're feeding about just over 9 hours a day. By July, it's up to about 11.5 hours a day, with July being the peak month, July and August being the 2 highest, and then declining as we head towards September. And then in contrast, the winter months here, and this again is the low elevation, December being the low for these animals on low elevation, or feeding the least amount of time, about 8.5 hours a day. And then picking up in February and March, and depending on the winter ranges, the low elevation winter ranges, as I said, some are as low as 1,500 meters, and those winter ranges that are that low can actually start greening up in February and have substantial green up by March. And this, the data for this particular graphic was from one of those lowest elevation winter ranges. So they're really starting to feed more as that forage becomes more readily available. And in contrast, again, you know, this animal that's, or these animals that we're feeding in the Alpine, they're only feeding about 6.5 hours a day in February. So looks to be, you know, about 2.5 hours less of feeding per day. And that again is seen here when we just compare the February mean feeding time between those migrant and resident animals. So it certainly appears that these animals that are using the wintering in the Alpine, using those Alpine winter ranges, are trying to conserve energy. There's less high quality forage available to them, much less. So it certainly makes sense. I think they're also, you know, one of the trade-offs we see is that these individuals that are wintering in the Alpine, for the most part, have very low risk of predation up there. It's just not a place where mountain lions are living. There aren't other prey species, certainly not large mammal prey species, that are readily available to predators. Whereas using that low elevation winter range, that's more of a concern. So in the Alpine, if you've found a safe spot with a patch of food that's wind scoured, you don't have to move around much to survive. So just to conclude, you know, the more I work on bighorn sheep, and I've worked on bighorn in California in both the desert environments and these Alpine environments, as well as across the country, you know, I'm just never cease to be amazed at how well they're adapted to live in extremely harsh environments. And I think, you know, some of these strategies that we see sheep using in the Alpine actually translate to the desert as well, because of seasonal food scarcity. But in the Alpine, they're reducing their energy expenditures by using smaller home ranges, restricting travel during periods of deep snow, and foraging less and bedding more. And then I alluded to it earlier, you know, they're clearly relying on fat reserves to meet the energy demands when they're living in these Alpine environments. And it's been interesting to see some of the presentations this week, looking at carrying capacity, and that's one of the topics that I've been interested in during my career. And, you know, really beginning to understand to a greater degree how these stored fat reserves supplement what animals are able to acquire on winter ranges. I think that's a particularly important component for folks to think about when they're calculating carrying capacity estimates. So with that, I'd just like to acknowledge the funders. This effort has been funded through a variety of state and federal agencies, as well as some NGOs. And then I always like to thank the field assistants that I've had over the years, without whom this data wouldn't be possible. And we've got almost 20 years of data now, and there's a lot of folks who've been involved with that data collection. So with that, if there's a couple minutes left, I'm happy to take some questions.
Thanks for that, Tom. We actually do have a couple questions coming in. So the first one here is, are there body size differences between migrant and resident sheep?
You know, so one thing I didn't mention in this was that we actually see a lot of we see a high rate of switching almost within an individual. So one individual one year might winter in the Alpine, and then the next year winter at low elevation winter range. So it's the same individual. It certainly appears that, you know, we see animals that are lactating and non-lactating, for example, wintering in the Alpine. So, and as I mentioned in the presentation, the availability of Alpine winter ranges really varies. But what I will say relative to this question is that the animals that are the most successful at wintering in the Alpine are the largest body sizes and put on the most fat. You know, if it's a mild year, a lot of animals can make it through, but during the severe winters we've seen, it's the larger bodied, fatter animals that make it.
Perfect, thank you for that. So we do have a couple more questions, but unfortunately we're out of time. So I'm just going to ask you to kindly respond to those by hitting the type answer button in the Q&A function. And we will move on to our next presenter. So thank you very much for that great talk.
Thank you.